Hello everyone. Today's topic is speed and velocity. So we'll just quickly understand the definitions and the difference, and then go for questions. Speed is how fast or how slow an object moves. Just like in athletics, it's 100 meters race that everybody has to run. But one person comes first because obviously it takes the least time. So we say that the person is running very fast. So there we are not actually measuring the speed. We are calculating the speed by finding the time. So speed is the comparison of distance traveled per unit time. So you define speed as distance upon times. Now since we are considering distance to define it, so it is a scalar quantity. And the units meter per second. When we talk about speed, we have certain specific types of speeds. So the most common one which we see in the speedometer is instantaneous speed. As the name says, it is the speed at an instant of time. You can't calculate that, you just have to observe it from on the speedometer. Then we come across average speed. Average speed is again to be calculated. It is total distance traveled by an object upon total time, irrespective of the fact that how, with what speed or instantaneous speed we covered the distance. So it is simply total distance upon total time. Going by the same grounds, we also have velocity to be understood. Velocity is speed with a direction, in short, if you want to know, or we say it is displacement per unit time. Since we are talking about displacement, obviously it is a vector quantity. And the units meter per second. So it goes almost in the same way, but because the direction is involved, so it's a vector quantity, and we calculate velocity by the displacement. So velocity is not something which you're going to observe anywhere. You have to calculate that. Again, we also have average velocity, just like average speed, which is equal to total distance displacement. Divided by, let me just rub it, total displacement upon total time. Now just a little bit I think I should tell you before I start with the questions. It helps sometimes. Now given a certain speed and time to find the average speed. So it is possible that the object is covering certain journey with let us say some two distances. We break the total distance in two parts, and then we measure the time, and then when we calculate the average speed, you're going to write it like this only, and then it's simply d1 plus d2 upon t1 plus t2. So this is an easy one. Now it is possible that in some of the situations you're not given the distance or you're not given the time. Suppose I'm not given the distance, but I'm given the speeds of the two distances. So for d1, say the speed is v1, and for d2 speed is v2. d1 and d2 are not given. So in that case, what do we do? I need total distance. So for that, going by the formula, v is equal to d by t. From here I can calculate v1, and t1, t2 is of course given. So d will be v into t. So in this case, your average speed will be v1 t1 plus v2 t2 divided by t1 plus t2. So this is how you can find out. As we do questions, it will be more clear, but I'm just giving you an idea. So sometimes it may so happen that you are not provided the time. So you have for d1, the speed is v1. For d2 distance, the speed is v2. Time t1, t2 is not given. Then what do we do in that case? Then for that case, again we go by the same expression. d1 and d2 is given, but time is not there. Time will be then given as t1 upon v1 plus d2 upon v2. Right? So any of these methods you can use, but this is just to get you to familiarize with the method. But after that, once you do the questions, things will become more clear. So going by the first question, these are examples from NCERT. The first question is, the odometer of a car reads 2000 km at the start of the trip and 2400 km at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in km per hour and meter per second. This is an easy question. The distance traveled will be 2400 minus 2000, which is 400 km. The time taken is 8 hours. So we average again d by t, total distance upon total time. So 400 upon 8, when you calculate, it's 50. So answer is 50 km per hour. But if you see the question, it's also given to find the average speed in meter per second. So in order to convert 50 km into meter per second, it's very simple. Simply multiply with 5 by 18. That's called the conversion factor. So this becomes, you can solve it here, 25 by 9, like this is, we are doing physics, we are not doing mathematics. So I don't really advise students to go for very deep calculations. It's fine. So 125 by 9 is a very good answer. So this is the speed in meter per second. Now going to the next question. This is example 8.3. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same path. Find the average speed and average velocity. For these, to find out average speed and average velocity, here you must find out the distance and displacement first and then solve. So if you see, she goes to the pool from one end to the other and back. So the distance covered 180 meter, 90 plus 90. And displacement, Yes, you all guessed it correct. It will be 0 because her initial and final positions are same. Time taken is 1 minute 60 seconds. So average speed, total distance upon total time, which is 180 upon 63 meter per second, and average velocity 0. Okay, now this question is from the exercise of the book. It says Joseph jogs from one end to the other end B of a straight 300-meter road in 2 minutes and 30 seconds, and then turns around and jogs 100 meter back to point C in another 1 minute. What are the average speed and velocities in jogging from A to B and A to C? Okay, let's first draw the diagram. Okay, let this be the straight road A, B, which is 300 meters. He returns back to point C here, which is 100 meters. So this is the situation. Joseph goes from A to B and then from B to C. So this is the way he covers the path. So we are given you have the length of the path. So I'll write it like this: AB as 300 meters and BC as 100 meters. The time in going T1 is 2 minutes and 30 seconds, which is 120 plus 30, so 150 seconds. Time in returning back is 1 minute 60 seconds. So this is the how you get the breakup of the time also. Now you have to find out the average speed and velocity in two ways, in two cases. A part from A to B. In A to B, the distance is equal to displacement. It's the same straight line path, 300 meters, and time also 150 seconds for both. So now the average speed and average velocities will be same since it's the same straight line path. 300 upon 150, which is 2 meter per second. In the second situation, in going from A to B to C, the distance covered will be 300 plus 100, that is 400 meters. And displacement 200, because now he is 200 meters away from its initial position. Time taken will be same for both, 150 plus 60, that is 210 seconds. So average speed 400 upon 210, which is 40 upon 21 meter per second. And average velocity 200 upon 210. So 20 upon 21 meter per second. So now the two values are different because the situation is slightly different for average velocity. Similarly, you have another question. It is question number 3 of the exercise. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same path, there is less traffic and the average speed is 30 km per hour. What is the average speed for Abdul's trip? Now in this case, you can see very well that only velocities are mentioned, average speeds, and nothing else is given. So not even the time. So how do you understand this situation? So just again look at the diagram. You have one road like this. This is say home and school. So distance is d while going and d while coming. That is the catch over here. So once you understand this concept, then it becomes easy for you to solve. So total distance covered will be d. D going, d coming, and time, like I showed you in the calculation, T1 plus T2 will be d by V1 plus d by V2. See this. I showed you in the third example. So d by V1 and d2 by V2. In this case, d1, d2 are equal, so we put it as d. So now the average speed, total distance, so this is equal to total distance 2d and total time d by v1 plus d by v2. I'll just simplify and then put the values. So if you take the LCM, it becomes dv comma v1 plus v2 divided by v1 v2. We're taking the LCM in the denominator. D cancels here. So you have 2v1 v2 upon v1 plus v2. Now what are the two values? 20 and 30. So you just have to put the values. Don't get confused, it's getting mixed up. So here it's 40 and 1200 divided by 50. So answer is 24. Now very often the students make an error in the calculation of the speed over here and they just do 20 plus 30 by 2 as 25. That's not the way to do it. So check out this method correctly, follow the system and then do the calculations. Okay, enjoy the video and wait for the next one. Bye bye.